Hi there, welcome to my channel mathssl. This video about geometric series. So first I'm going to show you how to prove the formula, and then I will show you the concepts about this topic. So first of all, I'm going to write here the sum of the first n terms of a geometric series Sn is equal to a plus AR first term, then second term, then third term AR square plus so on plus AR power n minus 2, the second to last term plus AR n minus 1. So this is my equation 1. Multiply by the common ratio equation 1. So we're going to multiply by R. So the R multiply Sn is equal to, now you must write one position away from the first term. Why? Because I give you the reason. So you start from here. So you're gonna say AR, you're multiplying the Sn by R. So this become AR square plus so on plus AR n minus 2 plus AR n minus 1 plus AR power n. So this is my equation number 2 now. You multiply by the ratio R this equation 1, then we get this equation 2. Now, but you're gonna write one position away from the first position. A reason is this one, because we can cancel out the terms. So we shift to the right one position to the right when we're writing the second term, so that we can cancel out the terms. If I don't shift one position to the right, still we can cancel out. If I have to multiply by R this equation 1, so this become AR and this become AR square and this become AR cube plus so on plus this become AR n minus 1. Why? Because AR n minus 2 multiply R, the answer gonna be A. So this is power 1 here. So you must, when you multiply, power must add. So the R n minus 2 plus 1. So the result gonna be AR n minus 1. So on. If I multiply AR n minus 1, multiply R, then it's gonna be A R. This power is 1 here. The R power must add n minus 1 plus this 1, and that become AR, positive and negative cancel, AR power n. Then this AR I must write under here, AR, and this AR square I must write under here. But you only gonna subtract like terms, so still you're going to subtract these two, and when come to AR square, you're going to subtract these two. So you're gonna subtract 1 minus 2, and then you're only gonna left with A minus AR power n. So either way, that's why I shift one position to the right, so I can easily cancel out. It's actually the same thing, because second one position ahead. So that's why I shift to the right one position so that I can cancel out easily. So now I'm going to subtract 1 minus 2. So that's going to be Sn minus R. Sn is equal to, only left A here, and this positive and negative cancel, positive negative cancel, all the term positive negative cancel, positive negative cancel. So ARN minus 2, ARN minus 2 cancel, this is also cancelled, so we're only left with, because 1 minus 2, you are subtracting, this is a minus sign, so this is going to be a negative AR power n. So I'm going to factor and solve for Sn. So I'm going to factor Sn here, so the Sn is out, so we're left with 1 minus R. This side, you factor A out, we're left with 1 minus R power n. Now divide by 1 minus R to isolate Sn. So the Sn is going to be equal to A parentheses 1 minus R power n over 1 minus R. R shouldn't be equal to 1. Now we prove this formula, and then if you want to prove the second part of this formula we're using when R less than 1. But if R greater than 1, then we use the other formula. I'm going to show you now how to prove that also. So Sn, if I want to prove the second one, and then A 1 minus R power n over 1 minus R, multiply negative 1 and divide by negative 1. So that will give me negative A 1 minus R power n over minus outside 1 minus R. Now I can apply inside this negative sign A. This become negative 1, this become positive Rn. So the positive Rn I write first, and then negative 1 over same positive R and minus 1. So the R should not be equal to 1. This formula you're going to use when R is greater than 1. But I will show you, you can use either formula, both are equal to each other. For example, we got 2, 6, 18, so on till say 4372. This is the geometric sequence. Adding the terms of a geometric sequence then become geometric series. So if I say 2 plus 6 plus 18 plus so on plus 4372, so this is series. Sn is the sum of the first n terms, n is the number of terms, A is the first term, R is the constant ratio, or you can say common ratio. Now I'm going to show you geometric series questions so that you can understand the concepts of geometric series. So the first question says, calculate the sum of each of the following geometric series. So the first one, this is the series to 10 terms, and the second question is also to 10 terms. Let me show you how to solve this question. So first of all, identify the first term A and common ratio R. So remember, because our formula say Sn, we got two formula, remember. One is if R is greater than 1, and one is if is R ratio less than 1. You can use any one. Both formula equal to each other. And the second formula Sn, A parentheses 1 power R minus 1 parentheses 1 minus R power n over 1 minus R. R should not be equal to 1, and this one we use when r is less than 1. So first I need to find the a first term. I can see the first term is 3 here. A is equal to 3. And now I'm looking r ratio, common ratio, term 2 divided by term 1, so 12 divided by 3, the answer is 4. Now I can use the sum formula for a geometric series. So as now I can see the ratio r is greater than 1, so I can use this formula. Sn is equal to a parentheses r power n minus 1 over r minus 1. So he said to 10 terms, so we're looking S10. So the S10 is going to be equal to, I'm going to substitute all of these values into this formula. So the A is 3 and ratio is 4, and N we got 10 because we're looking S10. So 4 power 10 minus 1 over 4 minus 1. So calculate the sum. Use the calculator one time, the answer will be, so the answer is going to be equal to 1,048,575. So this is my final answer. Second question now, we again need to identify the first term and common ratio. So the first term is A is equal to negative 27, and the ratio, second term divided by the first term, answer will be negative 1 over 3. So the r is less than 1. So which means I can use the second formula, which is Sn is equal to a parentheses 1 minus r power n over 1 minus r. So again he wants the 10 term, so the n is going to be equal to 10. So this time we're again looking at 10. So a is negative 27. We're going to substitute everything into the formula. Parentheses 1 minus r, we got negative 1 over 3, and the power n, which is 10, over 1 minus r, we got negative 1 over 3. Now I'm going to simplify one time to find the answer. So I use my calculator. My answer is negative 20,25. Question number 2. Calculate the sum of each of the following geometric series. So this is part A, this is part B. Obviously, according to the formula, we need A and R and N. So in here, we don't have the number of terms. Now we need to find the number of terms first before we solve the question. First, we need to determine the number of terms in a series. So we equate Sn to the last term in the series and solve for n. So we got this last term, So identify the first term, common ratio, and the last term. So we got in this question, A we got 27, and the ratio we have 9 over 27, that will give me 1 over 3. And then the last term L we have 1 over 2,187. Or you can say this is Tn, same thing. Now I'm gonna first need to find the same like arithmetic series. First we use the nth term formula to find the number of terms. So we're gonna use the also geometric sequence formula to find the number of terms. So Tn, this is the geometric sequence formula, A R n minus 1. So the A first term we got 27, and the ratio we got 1 over 3, power n we don't know, n minus 1, but Tn is equal to 1 over 2,187. Now I'm going to simplify. So my subject of the formula is n, and we need to find the n. So 1 over 3 power n minus 1 I leave as is. 27 I'm switch over this side, become a division, so it's gonna be a 1 over 2187 multiplied 27, that will give me 1 over 59,049. Now from here you can solve this question two ways. You can apply the log or you can apply the exponent rules. So according to the exponent rule, so this is a 1 over 3, this also must be 1 over 3. So I'm going to use the calculator till I find the I'm gonna use the power 1 over 3 power. I make a little template on my calculator and see which give me 1 over 59,049. Whichever power gives me answer 1 over 59,049, that power I'm going to use. In this case is going to be 1 over 3. I'm going to use my calculator, and that will be 1 over 3 power 10. Now I can, bases are the same, and then I can equate the exponents. So the n minus 1 is equal to 10, therefore n become 11. Now if I want to use the log, let me show you log also. So we need to find the n minus 1, that's our subject of the formula. We apply the log of 1 over 59,049 to the base 1 over 3. 1 over 3 stay the base. Use my calculator. Answer gonna be 10. So the n minus 1 is equal to 10. Therefore n become equal to 11. Either way answer will be the same. So we got a is equal to 27, and ratio we have 1 over 3, and the n we got equal to 11. So the r is less than 1, I can apply the less than 1 formula. So it's gonna be, I'm gonna apply this formula, Sn is equal to a parentheses 1 minus r power n over 1 minus r. So this is gonna be S11 because n is 11. 27 and 1 minus r, we got 1 over 3, and the power n, which we got 11 in this case, over 1 minus r, we got 1 over 3. I use my calculator one time, the answer is 40,50. So this is my S11, this is my final answer. Question 2, the B part. Now must remember here, for our formula we need a, and we need ratio, and we need n as well. So we don't have the n number of term, so that's why I'm gonna use, first I need to find the number of term. So I'm going to use the geometric sequence formula to find the number of terms, and the last term what we have, so we're gonna equate geometric sequence formula with the last term to find the number of term n. So first of all I need to find the number of terms. The first, identify the first term, common ratio, and the last term. So we have the a, we got 3, and the ratio we have second term divided by the first term, the answer is -2. And the last term we have, the last term we got -1536. So now I need to determine the number of terms. So the Tn is equal to a r power n minus 1. So substitute the value. So this Tn, the last term, -1536 is equal to first term we got 3, and the ratio we got -2 power n minus 1, because the n we don't know. Now divide both sides by 3, because we need to find the n, we need to isolate the n. N is our subject of the formula. So this become 1536 divided by 3. Both sides you divide by 3. So this side we left with negative 2 power n minus 1. I use my calculator. Negative 512 is equal to negative 2 power n minus 1. Now there's two ways to solve this question. I will show you from here. You can apply the exponent rule, or you can use the log, or you can use the log rule. So first let me do both ways. Let me apply the exponent rule. Express negative 512 as a power of negative 2, because if the bases are equal, then I can equate the power. So use your calculator, and negative 2 power, now use the calculator, make a little template, see which power give you negative 512, and then that power I'm gonna equate with n negative 1. So here we got 9. Negative 2 power n minus 1. Now I can see the bases are same, I can equate the power. So therefore n negative 1 is equal to gonna be 9. So n become negative 1, I pull over this side, become positive, so n is equal to 10. Or I can apply the logarithm here. From here I can apply the log also, your choice. That's the second method. You apply the absolute value. Absolute value will make negative positive. So this becomes 512 because you can't take the log on negative value. So this becomes 2 power n negative 1. Now I can apply the log. So I need to find the n negative 1. N negative 1 is equal to log of 512 to the base 2. 2 will stay the base. I use my calculator. So my answer is 9. N negative 1. So the n become 10. Same answer. Either way you can find the n. Now, so we got now n. Now I can find the sum of the series, which means I'm looking S10. First 10 terms of the series. So I've got A and the ratio, and I got the n. Now I can find the S10. So the Sn formula, you can use any formula. Must remember, I told you if r is less than 1 or r is greater than 1, any formula you can use. So now we're going to use the formula Sn is equal to A r power n minus 1 over r minus 1. But remember, I told you if the ratio is r is less than 1, then you can use 1 minus r formula. But even you use r negative 1 formula is same. Either any formula you can use, the answer will be the same. Even you can use this one, or you can use this formula Sn is equal to A 1 minus r power n over 1 minus r. This you will use when r is greater than 1. This we use when r is less than 1. Even r is less than 1, you still can use this formula, the answer will be the same. So any formula you can use. Doesn't mean you have to look specific now. You can choose one formula and you can use standard formula. Every time you can use that formula. Even r less than 1 or greater than 1, every time you can use even this formula, doesn't matter. So I'm going to use this one. Now I'm gonna substitute the value. This becomes 3 and negative 2 power 10, because we're going to find the S10, and negative 1 over the ratio we got negative 2 minus 1. I use my calculator. One time the answer is negative 1023. This is my final answer. And this is the last concept about this chapter. Then I'm going to show you the problem. We can determine the number of terms that will add up to specific value by equating Sn to the given value and solving for n. So the question says, consider the geometric series And the first question says, how many terms of the series will add up to 13,120 over 27? Second question, determine the least number of terms for which the sum of the series will be greater than 485. So we start with first part A. So identify the first term and common ratio here. So the first term we got here, A is equal to 324, and the ratio we have second term divided by first term. The answer will be 1 over 3. I use my calculator. Now use the sum of a geometric series formula to find the n. Now, so here the ratio is less than r is less than 1. R is less than 1, so I can use the formula r less than 1. Even I want to use the formula r greater than 1, I can use. Doesn't matter. Both formula equal to each other. So I'm going to use this formula. So the Sn is equal to a power a parentheses 1 minus r power n over 1 minus r. So Sn is equal to 13,120 over 27. So Sn is 13,120 over 27 is equal to, the first term we got 324, big bracket 1 minus r, we got 1 over 3, the ratio power n we need to find, we don't know the n, big bracket close, over 1 minus 1 over 3. So my subject of the formula is n, so I need to find the solve for n here. So 13,120 over 27 is equal to, now I'm going to solve 324 divided by 1 minus 1 over 3, 486. 324 divided by 1 minus 1 over 3, answer is 486, bracket 1 minus 1 over 3 power n. Now 486, when I switch over this side, become division form. 27 multiply 486 is equal to 1 minus 1 over 3 power n. I'm going to solve here further. 13,120 over 13,122. I'm going to further simplify now because we need to solve for n here. 1 over 3 I pull over this side, become positive. 1 over 3 power n is equal to 1. This become minus 13,120 over 13,122. I use my calculator. The answer is 1 over 6,561, and this shall be equal 1 over 3 power n. Now from here I can apply the log or I can apply the exponent rule. The answer will be the same. So we're looking now 3 power, we use calculator, which give me 6,561, and that power I'm gonna use. So 3 power 8 is equal to 6,561. Therefore 1 over 3 power n is equal to 1 over 3 power 8. So the bases are same, so I can equate the power. So therefore the n is going to be equal to 8. Or I can apply log here. I show you now log. Or I can apply log here. N is equal to log of 1 over 6,561. Log of 1 over 6,561 to the base 1 over 3. So that my answer is 8. Either way, the answer will be the same. So the n is equal to 8. So therefore 8 terms. Now the part B. Determine the least number of terms for which the sum of the series will be greater than 485. Set up the inequality and using the same formula, Sn is equal to a parentheses 1 minus r power n over 1 minus r. This formula we're using when r is less than 1. Even I can use the formula r greater than 1. The answer will be the same because the both formula they are equal to each other. So I'm going to use this formula here. So which means Sn must be greater than 485. Now I can equate with greater sign, or I can even equate like this also, Sn equal to 485. Then I find the answer. Then after that I can give the answer greater than 485. So I'm gonna equate. So a we got 324 big bracket 1 minus, and the ratio we got 1 over 3 power n big bracket close over 1 minus r, which we got 1 over 3, is equal to 485. Some of the learners they get mistake when they write greater sign, so you can even write the equal sign or greater sign, doesn't matter. At the last you can round off the answer. 324 divided by 2 over 3, because our subject of the formula is n. So we're going to solve for n here. So this become 486. Big bracket 1 minus 1 over 3 power n big bracket close is equal to 485. Both sides you divide by 486, or 486 you pull over this side, become under fraction. Left hand side is on multiplication form, and I switch over to the right hand side, become division form. So the 1 minus 1 over 3 power n is equal to 485 over 486. So first of all, my subject of the formula is n. So negative 1 over 3 power n and 485 over 486, positive 1 become negative 1 when I pull over this side. This is the one option. I show you if it's like this how to do. And the second option is this one. I can swap around. Negative 1 over 3, if I pull over right hand side, become positive, and 485 over 486, if I pull left hand side, become negative. Now our subject of the formula is n, so we need to solve n. Now negative 1 over 3 power n is equal to, this become negative 1 over 486. Now this is negative sign, this is negative sign. This negative sign outside the bracket, so I can cancel because both sides is negative, negative cancel. So we only left with 1 over 3 power n is equal to 1 over 486. So I would like to use the log. But remember, you can't apply exponent rule here. You must apply the log. When they give you inequality sign greater than or less than, must apply log. But if it's an equal sign, when you are equating, then you can apply log, or you can apply the exponent rule. Because the answer gonna come in decimal, we need to round off the answer. So that's why the log will be the best choice. So the only you have to apply the log. Exponent not gonna work. So we got inequality sign, so I'm gonna apply the log. So n I need to find. N is equal to log of 1 over 486 to the base 1 over 3. I use my calculator. The answer is 5,63. Now I need to round off the answer because Sn greater than 485. For Sn greater than 485, so n must be a greater than 5,63. So the greater than 5,63 whole number, nearest whole number is 6. So therefore n is going to be equal to 6. So which means the 6 terms. So this is my final answer. Or you can leave answer till here, doesn't matter. This is a question number 4, not a C. He said how many terms of geometric series must be added to obtain the given sum. So this is the geometric series. So we need to equate with this one. Now identify the first term a and common ratio r. So the a we got 3/4 and the common ratio we got -3/8 over 3/4. I use my calculator. The answer is -1/2. Now use the sum of a geometric series formula. R is less than 1. I can use the R less than 1 formula or R greater than 1. Doesn't matter, same thing. So I'm going to use this one. R less than 1. So the formula Sn is equal to A parentheses 1 minus R power n over 1 minus R. I'm using the formula R less than 1. Now I'm going to substitute the known values. So Sn we got 513 over 1024 is equal to A we got 3/4. 1 minus the ratio we got -1/2 power n big bracket close over 1 minus r we got -1/2. I'm going to simplify the equation now. So 513 over 1024 is equal to 3/4 big bracket 1 minus -1/2 power n big bracket close over 3/2. So I'm gonna further simplify. 513 over 1024 is equal to, this become 1/2. 3/4 divided by 3/2 is 1/2. Big bracket 1 minus -1/2 power n big bracket close. Now our subject of the formula is n. So 1/2 as switch over this side become, this is a division, become multiplication. 513 multiply 2. That will be, give me answer 1026 over 1024. And this side we got 1 minus -1/2 power n. From here I'm going to show you a couple of ways how to solve equation algebraically. Now first of all, here must remember our subject of the formula is n. So -1/2 power n, I pull over this side, become, this negative sign become positive because this negative sign belong to -1/2 power n. So this become -1/2 power n. I swap around. Example, negative parentheses -a power n. So now you taking this variable, that should become positive. We applied same concept here. Equal to 1, this term become minus, positive become minus 1026 over 1024. Now I'm going to further simplify. Is equal to, this become -1 over 512. Remember, in previous question I told you, when is inequality sign, greater than sign or the less than sign, we have to use the log. You can't use the exponents because the answer gonna be in decimal. Then we have to round off the answer. But if you got equal sign, then I can use the log or I can use the exponent rule. So here we are equating. So we don't have an inequality sign here, greater than or less than. So we are equating here. So I can use the log or I can use the exponent rule. I'll show you both way how to solve the question. So let's do first exponent rule. Exponent rule is easy. Must remember negative 1 over 2 power n. This set also must be negative 1 over 2 power something, and then we can same basis, then we can equate the powers. We looking now 512 equal to 2 power. Leave the fraction, only this one. 2 power what? So you make a little template in your calculator. Try 2 power 1 is 2, 2 power 2 is 4, so on. So the 2 power 9 gonna be 512. So which means 2 power 9. That is satisfy the condition. So this become negative 1 over 2 power n, and this had become negative 1 over 2 power 9. Bases are same. Now I can equate the exponents. So the n is equal to 9. So this is my final answer. Now I'm going to show you how to apply the log. Now log you cannot apply. From here I can apply the log also, but you can't apply the log on negative value. So there's two ways to solve this one. The first method, I can apply the absolute value. Absolute value, remove the negative sign from the number, then number become positive. So the negative 1 over 2 power n absolute value is equal to negative 1 over 512 absolute value. So this become 1 over 2 power n is equal to 1 over 512. Now I can apply the log because now the values are positive. I need to find the n. So the n is equal to log of 1 over 512 to the base 1 over 2. My answer, I use my calculator, my answer is 9. So either way answer is same. But now if you don't apply the absolute value, then you have to use, still you can use the exponent rule, and then you don't need to apply absolute value, then you can still use the log. I'll show you that method. So must remember both sides signs are negative. That means n must be an odd number for real solution. This allows the equation to be rewritten without the negative sign. So I can write now 1 over 2 power n is equal to 1 over 512. So I can write 1 over 2 power n is equal to 1 over 512. Now I can apply the log. What is mean by this? That the both sides are negative sign, and that means n must be an odd number. This allows the equation to be rewritten without the negative sign. Say we got negative 3 power 3 is equal to negative 27. Same, this is parentheses, and no parentheses, no parentheses. Now this means negative 3 multiply negative 3 multiply negative 3 is equal to, answer gonna be equal to negative 27. So which means negative 27 left hand side, right hand side also negative 27. Negative cancel, can you see become positive. So that's why when you see both sides are negative sign, that means the n gonna be a odd number. This allows the equation to be rewritten without the negative sign. So you don't need to apply the absolute value, then you can write like this. but I like absolute value. Now you can apply the log to solve this one. So now I can apply log to solve n. Just argument's sake, I want to clear the concept properly. This is not a part of that question. That question is done. Say we got now one side positive and the one side is negative. Right hand side we got positive, the left hand side we got negative. So how to get rid of the left hand side negative sign? Let me show you. So the left side has a negative base, but the right side is positive. So don't forget this one. We talk about the base. So this means n must be a even number. N must be a even integer. Can be n minus 1 on top also. Doesn't matter. Even power is n minus 1. Still we can apply the same rule. This means the n must be a even integer. So the right hand side can also be written with a negative base, or even this negative I can change to the positive, either way. So I can write like this: negative 1 over 2 power n is equal to negative 1 over 1024. Or I can write like this also: 1 over 2 power n, and this is 1 over 1024. Still same thing. Either I can make left hand side positive, or I can make right hand side negative. Now I can further solve. I can apply here log, because this is a positive. Now why did we do this one? Let me show you the logic. Negative 2 power 2. That means negative 2 multiply negative 2, the answer is positive 4. And if you go 2 power 2, answer still gonna be 2 multiply 2, answer is 4. As long as the exponent is even, the base can be negative or positive, doesn't matter, the answer gonna be still positive. One side is positive, the other side is negative. Right hand side is positive, left hand side is negative. This means n must be an even integer, so then I can apply this logic. Now this is algebraically. Oh, I already explained to you in previous videos. You can apply the absolute values as well. This one I just teach you something extra you need in sequences and series to apply these concepts. Now there is harmonic progression as well, but that is in overseas mathematics books, but we don't have in South Africa. A sequence of numbers is called a harmonic sequence or harmonic progression if the reciprocals of its terms are in arithmetic progression. So if the is like this: 1 over 3, 1 over 5, 1 over 7. So 1, 3, 5, 7. So this is a AP, arithmetic progression, but is now in, you're writing in, this is 1 over 1 na? So you're writing in reciprocals, so this become harmonic progression. Just for interest sake I told you, otherwise we don't need in South Africa. Question 5. The sum of the first three terms of a geometric series is 52 and the sum of the next three terms is 1404. Determine the first term and the constant ratio of the series. I'll show you this question. You can solve two ways this question. Let me show you the first method. This is the easy method. I like this method. Especially geometric series, you can apply this method. But in arithmetic series also you can apply, but you can use the formula even there. But I will show you how to solve with formula as well. Let me do the first method. I'm gonna solve according to the terms, and the second method according to the formula. Set up the equations for the sums of terms. So let the first term be a and the common ratio be r. We learn from this is from the proof of the formula. So that is the geometric series. Take the common factor here. The common factor is a here, and what we left with 1 plus r square is equal to 52. So this is my equation number 1. Now the next three terms are, that's gonna be ar power 3, because these are the first three terms, and our next three terms, and the ar power 4, ar power 5, and their sum is and this is a sequence and now geometric series. Ar power 3 plus ar power 4 plus ar power 5 is equal to 1404. This time factoring out ar power 3. So this is common factor. Ar power 3, and we're left with 1 plus r plus r power 2, and is equal to 1404. This is my equation number 2. Now we're gonna solve for the common ratio r. Divide the second equation by the first equation. So the second equation we got ar power 3 1 plus r square over, and the variable of that side for first equation is a, left hand side 1 plus r square, and now equal to 1404, and there's the constant is 52, divide by 52. So now this is cancel out, and also a is cancel out. We left with r power 3, and we use the calculator. This side is gonna be r power 3, and this become 1404 divided by 52 is 27. Now I'm gonna take the cube root of both sides. So I'm gonna take the cube root of both sides. So my answer is r is equal to 3. Now we're gonna solve for the first term a. Substitute r is equal to 3 back into the first equation. Even you can put in second equation, doesn't matter. So the first equation we have a 1 plus r power 2 is equal to 52. Now place of r we're gonna put the 3. So the a 1 plus 3 power 2 is equal to 52. So this becomes 13a is equal to 52. Therefore a is gonna be 52 divided by 13, 4. So my final answer is there. We got the a is 4, and the common ratio we got 3. So this is my final answer. So this method we solve the question according to the sum of terms. Now I'm gonna show you the method according to geometric sum formula. This method you can apply also in arithmetic series, this type of questions. In geometric series, common ratio term 2 divided by term 1, that's why equation 2 divided by equation 1. In arithmetic series, term common difference term 2 minus term 1. So if you want to apply this method in arithmetic series, then you're gonna take from term 2 minus the term 1. So anyhow, and you can solve this question with formula as well in arithmetic series. This type of question I remembered in my previous video. I'll solve for you according to the formula. So I would like to show you also this question according to the formula. According to the formula, arithmetic series is easy, but according to the formula, if you want to solve this geometric series, is a little bit hectic, but I'll show you how to do. But this method is more easy. I think you can use this method, but I'll show you that method as well now. Now I'm gonna solve this question according to the formula. You can use this method or the previous method. So first of all, define the sum of terms. So first of all, so the sum of the first three terms S3 is given by as 52. So S3, we're gonna use geometric series sum formula. So the S3 is equal to 52, and S6, because he said the next three terms is equal to 1404. So the S6, the first six term, so which means S3 plus now this next three terms. So the next three term sum is 1404. So that will be 1404. So S3 already we got equal to 52. So the 52 plus 1404, the total will be 1456. So this is your S6. So now I'm gonna use the general formula for the sum of a geometric series, which is Sn is equal to a r power n minus 1 over r minus 1. So using the Sn formula, two equations can be established. So the first gonna be S3 is equal to a parentheses and place of n we're gonna say 3 now, r power 3 minus 1 over r minus 1 and is equal to 52. And the S6 is going to be equal to a r power 6 minus 1 over r minus 1 is equal to 1456. To find the common ratio r, divide the equation for S6 by the equation for S3. S6 divided by S3, and that is equal to gonna be 1456 divided by 52, and S6 is equal to this formula and S3 is equal to this formula. So we're gonna substitute these formula place of S6 and S3, and then we're gonna further solve. So the S6 we got a r power 6 minus 1 over r minus 1 divided by S3, which we got a r power 3 minus 1 over r minus 1 is equal to 1456 divided by 52. This r minus 1 and this r minus 1 is cancelled. This a and a is cancelled, because if I'm gonna invert, it's gonna be same thing. Have a look here. A r power 6 minus 1 over r minus 1 multiply now r minus 1 inverts, and this become a r power 3 minus 1. So I can now cancel. This is cancelled. This is cancelled. So we only left with r power 6 minus 1 and r power 3 minus 1. So same thing, even under the fraction you can cancel like this. Even you can cancel like this, or you can bring to this multiplication form and then you can cancel. Either way. So now we left with r power 6 minus 1 over r power 3 minus 1, and this side is equal to 28. Now we're gonna factor the numerator using the difference of squares formula. Now I'm gonna factor the numerator using the difference of squares formula. So the top is gonna be r power 3 minus 1, and one term with a negative sign and one term with a positive sign, over r power 3 minus 1 is equal to 28. Now this is cancelled, so we only left with r power 3 plus 1 is equal to 28. Now r power 3, 28, positive 1 become negative, so r power 3 is equal to 27. Apply the cube roots both sides. The answer will be r is going to be equal to 3. So we got the r. Now find the first term. Substitute the r equal to 3 back into the equation for S3. Even you can substitute into S6 also, but I'm going to substitute into the S3. So r equal to 3, I'm going to substitute into the S3. So the answer is going to be a. This becomes 3 power 3 minus 1 over 3 minus 1. I use my calculator, and S3 is equal to 52, don't forget. Now this is going to be 26a, and divide by 2 is equal to 52, and 13a is equal to 52. Therefore a is going to be equal to 4. Both sides you divide by 13. So now according to this method, the a is 4 first term, and the common ratio is r is equal to 3. Either way, answer is the same. You can use the sum of terms method, or you can apply the sum of geometric series formula. Either way, answer will be the same. This is DBE exam question, November 2022. The first term of a geometric series is 14, and sixth term is 448. First question, calculate the value of the constant ratio. First term given, a is equal to 14, and the T6 he say is equal to 448. I can apply here the formula for the nth term of a geometric sequence. Tn is equal to a r power n minus 1. Some of the learners might confuse. They're going to say talk about series, but you're using the sequence. Must remember, according to the demand of the question. And by the way, geometric series formula, we need a, and we need r, and we need n, then we can apply. So all of these we don't have, we only got a. So that's why we have to apply this formula to obtain the common ratio. So substitute the known values into the formula. So we got 448 Tn. Say we need to find the T6 now. In place of n, I substitute 6. First term we got 14. R we don't know. The n is 6 minus 1, because this is a sixth term. So this is gonna be T6 is equal to 448 is equal to 14 r power 5. Now solve for r power 5 here. So the r power 5 is gonna be equal to 448 divided by 14. Now I'm gonna pull this question this side. So this is gonna be r power 5 is equal to 32. So now solve for r. So this is exponent. When I pull over this side, become root form. So it's become fifth root. So I use my calculator. The answer is 2. So therefore r is 2. Second question, he said determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of 114,674. So the SNs, which mean total, so that it must be equal to 114,674. So this is total, S total. The sum of the 6 terms is S6. The number of additional terms needed is, we say K. We give the name K. S6 plus K is equal to gonna be, that make S total, Sn. So you need to understand the first question properly. So the sum of the first 6 terms is S6. Determine the number of consecutive terms that must be added to the first 6 terms. So this is the first 6 term. So that number what need to be added, we don't know, we need to find now. So 6 plus K, that's why become S, and S total is equal to S total. Right, so this is already given to you. You say in order to obtain a sum of so the Sn. So this is already given to you. So now if I need to find the K, as total mean Sn. So if I need to find the K now, so which mean from the total I must minus the 6, then I will know the K. Then I will know how many number of terms to be added to the first 6 terms. We're going to use the formula for the sum of a geometric series. Sn is equal to a r power n minus 1 over r minus 1. This formula I'm going to use. Now we need to substitute the value what we know. So Sn total already given to us, which is 114,674 is equal to, first term we got 14, and the ratio we earlier found 2 power n minus 1 over 2 minus 1. So I'm going to further simplify. 114,674 is equal to 14 parentheses 2 power n minus 1, because 2 minus 1 is 1. So the divided by 1, this is the answer. Solve for n here. 114,674 divided by 14. I pull over 14, this side become division. 2 power n minus 1. Further simplify, this is going to be 8,191 is equal to 2 power n minus 1. So the minus 1 I pull over this side become positive. So this is going to be 8,192 is equal to 2 power n. So you can apply the logarithm or you can apply the exponent rule to solve here. I'm going to apply the logarithm. So I'm going to apply the log. So n is equal to log of 8,192 to the base 2. So I use my calculator. The answer is 13. So the total number of terms 13. Now we need to determine the number of additional terms to be added. So must remember the K is equal to n minus 6. So the n total we got 13 minus this 6. Answer is 7. So which means the number of consecutive terms that must be added is 7. So this is my final answer. Question 7. Calculate the sum of the first 20 terms of the series. Now, I don't want to add this question, but not so important, but sometimes you never know, they can ask this question also. So I want to close all the whole. So this is the mixed series. Sometimes they will give you the mixed series made up of 2 different series. And in such cases, we have to first calculate the sum of each series. separately and then add the answers together. So we got two series here. Two series are combined. So 1 5 plus 9 plus 13, and then we got 1 over 2 plus 1 over 4 plus 1 over 3 plus 1 over 16. Alright, look the first one. 1 plus 5 plus 9 plus 13. This is arithmetic series. And 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16. This is geometric series. So here looking first 20 terms. 10 terms are arithmetic series and the 10 terms are geometric series. So I need to find the S term for the arithmetic series and then S10 also for geometric series. So first apply the arithmetic series. 10 over 2 big bracket 2 and the first term is 1a plus 10 minus 1 and the difference is 4. Multiply 4 big bracket close. I use my calculator one time. Answer is 190. Now I'm going to use the geometric series. Now this is a geometric series. We're going to use the geometric series sum formula. S10 is equal to 1 over 2 the a big bracket 1 minus the ratio is 1 over 2. So the 1 over 2 is the ratio, power 10 close bracket over 1 minus 1 over 2. Ratio you will find 1 over 4 divided by 1 over 2. The answer is going to be 1 over 2. So I use my calculator one time. So the answer is going to be 0.9990. Therefore S20 will be arithmetic series 190 plus this 0.9990 geometric series, and the final answer is 190,9990. So this is my final answer. Please like and subscribe. If you have any question, comment below. I will assist you. Have a nice day. Thanks for watching. Stay tuned for my next video where I will explain the sum to infinity formula for geometric series.